Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today I want to discuss about some problems on exact differential equations. In the previous video, we discussed about what is the exact differential equation and what is the condition for the exactness and how to solve the exact differential equations we discussed. So here we are going to discuss some more problems on exact differential equation. So already we know this. What is the exact differential equation? So here m of x comma y into dx plus n of x comma y into dy equal to 0 be a first order and first degree differential equation. So here in this equation we are having first order and first degree, and m and n are the real values functions of x comma y. So this is the form of the exact differential equation, that is nothing but m dx plus n dy equal to 0 is said to be exact differential equation. So how we can say that the given equation is exact differential equation? We can observe here for the condition for the exactness. So if m of x comma y and n of x comma y are two real functions which have continuous partial derivatives, then the necessary and sufficient condition for the differential equation is dou m by dou y is equal to dou n by dou x. If dou m by dou y is equal to dou n by dou x, then we can say that this given equation is exact differential equation. If the condition is proved, we have to follow the procedure to calculate the general solution. What is the general solution here? Integral m dx plus integral n dy equal to c. So when you are taking the m value, when you are doing the integration for the m, we should take y as a constant. And when you are considering the n value, we have to take it only y terms, free from x, only y terms. These should be important, and we have to take this value as only y terms. We should not take the x terms for the n. So what is the procedure we are going to follow here? First we have to consider the given equation is exact or not. So first we have to take the values of m and n. So what is the m value? What is the n value? We have to identify. After then, second condition, we have to calculate dou m by dou y and dou n by dou x values. These two values we are going to find. After then, we have to check about dou m by dou y is equal to dou n by dou x or not. If it is equal, then we have to find the general solution. What is the general solution? Integral m dx plus integral n dy equal to c. So this is the general solution. So first step, we are identifying the m and n values. After that, we are calculating dou m by dou y and dou n by dou x. And here, we are checking about the exactness. After that, we are writing the general solution. This is the procedure we are following here to solve the exact differential equation. You can observe the problem here. Solve cos x minus x cos y into dy minus sin y plus y sin x into dx equal to 0. So what is the given equation? The given equation is cos x minus x cos y into dx plus sin y, minus here, sin y plus y sin x into dx equal to 0. So here we are going to compare with the form m dx plus n dy equal to 0. So when you are comparing this form, this is the general form of the exact differential equation. So with the dx we are having m value. Here where is the dx? Here dx, here dy. So here dx means what is the m value here? M value equal to minus sin y minus y sin x. M value is minus sin y minus y sin x. And what is the n value? N value equal to cos x minus x cos y. Cos x minus x cos y. So after identifying the m and n values, what is the step we are doing? We are going to calculate dou m by dou y and dou n by dou x. So here, what is the dou m by dou y? We are going to calculate here. So dou m by dou y. That means we are doing the partial differentiation of m with respect to y. So here minus differentiation of sin y is cos y. Differentiation of sin y is cos y. Minus, here when you are doing with respect to y, x is the constant. So sin x is constant, y value is 1. So finally this value is minus cos y minus sin x. This is the dou m by dou y value. This is the dou m by dou y value. This is only we mentioned here. Next we are calculating dou n by dou x. What is the dou n by dou x? When you are doing with respect to x, y is the constant. So here cos x is there. So derivative of cos x is minus sin x. Derivative of cos x is minus sin x. And when you are doing with respect to x, y is the constant. So cos y is the constant. X derivative is 1. So finally here minus sin x minus cos y. So here the both values dou n by dou x is minus sin x minus cos y. Dou m by dou y also minus sin x minus cos y. So these two values are equal. Dou m by dou y is equal to dou n by dou x. So this is the exact differential equation. We can say that this is the exact differential equation. So now if it is equal, what we are going to follow? We are going to calculate the general solution. What is the general solution? Integral m dx plus integral n dy equal to c. So here when you are doing for the m, y treated as constant. When you are doing for the n, here we have to consider the n value only y terms. Only y terms. That you have to remember. So here we are going to calculate integral m dx plus integral n dy equal to c. So what is the m value? What is the m value? We can observe here m is minus sin y minus y sin x. Minus sin y minus y sin x into dx. That is the only we wrote here. And plus integral n value. Actually, what is the n value here? Cos x minus x cos y. What is the n value? Cos x minus x cos y. Here, there is any only y term here? No, we don't have the y term, and there is no possibility to take the y value separately also in the n. So that's why we will consider n value as 0. So integral 0 into dy equal to c. That's why we wrote here 0. So here integral 0 is 0, and here minus integral sin y dx minus integral y sin x dx equal to c. So finally minus, here when you are doing with respect to x, y is the constant. So minus sin y is the constant. Integral dx value is x. Integral dx value is x. Minus, here y is constant, integral sin x dx. So that is minus cos x equal to c. So finally what is this value? Minus x into sin y plus cos x into y equal to c. Cos x into y equal to c. So this is only we got here. This is the general solution of the given differential equation. So this is the way to calculate the general solution for the given exact differential equation. So to get the better clarity, we are moving for one more example. We can observe here. Solve 1 plus e power x by y into dx plus e power x by y into 1 minus x by y into dy equal to 0. So what is the given equation first? The given equation is, so in every problem you have to write the given data. So that's why what is the given equation? What are the values and for which value we are going to compare to take the m and n value? These details you have to write. So given equation is 1 plus e power x by y into dx plus e power x by y into 1 minus x by y into dy equal to 0. 0. Here we are going to compare this equation with the general form. What is the general form? M dx plus N dy equal to 0. So when you are comparing with this general form of the differential equation, so what is the m value, what is the n value? So first of all, we are writing here what is the m value. M dx means here m value is 1 plus e power x by y. 1 plus e power x by y. That is only we wrote here. And what is the n value? N value is e power x by y into 1 minus x by y. This is the n value. So e power x by y into 1 minus x by y. Now we are going to calculate dou m by dou y. What we are going to calculate here? Dou m by, that means partial differentiation of m with respect to y. So here 1 is the constant, so that value is 0. Here e power x derivative is e power x only. That means in place of x we are having e power x by y. So e power x by y derivative is e power x by y, and we have to do the differentiation for the power value also. Here when you are doing with respect to y, so x is the constant. So x into 1 by y differentiation is minus 1 by y square, minus 1 by y square. So finally this value is minus x by y square into e power x by y, minus x by y square into e power x by y. That is the dou m by dou y value. And now we are going to calculate dou n by dou x. Dou n by dou x. So here we are following the u into v formula. What is the derivative of u into v? U derivative of v plus v derivative of u. This formula we are going to follow here for the n. So here e power xy is u. So derivative of v first we are doing. So 1 is the constant 0. Minus here with respect to x we are doing. So 1 by y is the constant. X value is 1. So this is the first one, that is u dv. Plus v du. 1 minus x by y is the constant. Derivative of e power x by y. So derivative of e power x by y is e power x by y. And 1 by y is the constant, x value is 1. Now we are calculating here. So we can observe here dou n by dou x equal to e power x by y into 0, 0 minus here minus 1 by y into e power x by y. This is the first term. So next here I am going to multiply. So 1 into 1 by y. That's plus 1 by y into e power x by y. 1 by y into e power x by y. Next term is minus x by 1 by y into 1 by y is 1 by y square e power x by y. Now plus 1 by y minus 1 by y will be cancelled. So dou n by dou x value is minus x by y square into e power x by y. So this is the value of dou n by dou x. So finally dou n by dou y value also e power x by y into minus x by y square. Dou n by dou x value also e power x by y into minus x by y square. So here dou m by dou y is equal to dou n by dou x. So both values are equal. We can say that this equation is exact. We can say that this equation is exact. So after knowing this equation is exact, we have to calculate the general solution. So we can observe here what is the general solution. General solution is integral m dx plus integral n dy equal to c. So integral m dx plus integral n dy equal to c. Here for the m, y is constant. For the n, we will take only y terms. Only y terms. So what is the m value? M value is, we can observe here, 1 plus e power x by y. M value is 1 plus e power x by y. And what is the n value? N value is e power x by y into 1 minus x by y. E power x by y into 1 minus x by y. So m value, so 1 plus e power x by y into dx. Plus here in the n, if you are multiplying also, we are getting here e power x by y minus x by y into e power x by y. So there is no separate y terms here, and there is no possibility to separate the y terms from the given value. So that's why we are taking n value is 0. So n is 0 here. So here we are going to integrate integral 1 into dx plus integral e power x by y into dx plus here integral 0 dy is 0 equal to c. Finally, this value integral 1 into dx is integral dx is x plus integral e power x by y. So integral e power x is e power x by 1, right? So e power x by y by. If it is differentiative, we will write into. So if it is integral, we will write in the denominator. So by here with respect to x, y is a constant. 1 by y is a constant. X value is 1 plus 0 equal to c. So finally this is x plus y into e power x by y equal to c. This is only our general solution. This is only our general solution. So this is the general solution of given equation, that is 1 plus e power x by y into dx plus e power x by y into 1 minus x by y into dy equal to 0. So here we are going to discuss one more problem. We can see. So solve y into 1 plus 1 by x plus cos y into dx plus x plus log x minus x sin y into dy equal to 0. So first of all, we are writing the given equation. What is the given equation? Given equation is y into 1 plus 1 by x into plus cos y. Y into 1 plus 1 by x plus cos y into dx plus x plus log x minus x sin y. X plus log x minus x sin y into dy equal to 0. Now we are going to compare with the general form, that is m dx plus n dy equal to 0. M dx plus n dy equal to 0. So what is the m value when you are comparing here? M value is y into 1 plus 1 by x plus cos y, and n value is x plus log x minus x sin y. Log x minus x sin y. Now I am going to calculate dou m by dou y value. So dou m by dou y equal to, here I am going to calculate m value with respect to y. So y here, y value is 1. Differentiation of y is 1 plus 1 by x is the constant. Differentiation of y is 1 plus cos y. Cos y derivative is minus sin y. Cos y derivative is minus sin y. Finally, this value is 1 plus 1 by x minus sin y. Minus sin. This is the value of dou m by dou y. Now I am going to calculate dou n by dou x. What is the dou n by dou x here? With respect to x, x is 1 plus log x differentiation is 1 by x minus, when you are doing with respect to x, y is the constant. So sin y is the constant. X value is 1. So finally this is 1 plus 1 by x minus sin y. So here also for the dou m by dou y, we got 1 plus 1 by x minus sin y. For the dou n by dou x also, we got 1 plus 1 by x minus sin y. So these both values are equal. So that means dou m by dou y is equal to dou n by dou x. Dou m by dou y is equal to dou n by dou x. So here exact condition is satisfied. So that means the given equation is exact differential equation. So after knowing this value, what we are going to do? We are going to find the general solution. What is the general solution? Integral m dx plus integral n dy equal to c. So what is the m here? Here we will take m value and we treat it as y as constant, and for the n value we will take only y terms. So what is the m value here? M value is y into 1 plus 1 by x. Y into 1 plus 1 by x plus cos y. This is the m value. And what is the n value? N value is x plus log x minus x sin y. X plus log x minus x sin y. This is the n value. Here there is no separate y term and there is no possibility to separate the y term also in the given value. So That's why we are taking n as 0. So we are replacing here n value as 0, and here for the m value is y into 1 plus 1 by x. We are writing y plus y by x plus cos y into dx plus 0 into dy equal to c. So here we are integrating y dx plus integral y by x dx plus integral cos y into dx plus 0 equal to c. So what is the integral y dx? Y is a constant. Integral dx is x plus, and y is also constant. Integral 1 by x dx is log x plus integral cos y, means cos y is a constant. Integral dx is x equal to c. So finally we got here x into xy plus y log x plus x cos y equal to c. So when you are taking y common here, this one is x plus log x plus log x plus x cos y equal to c. X plus y into x plus log x plus x cos y. This is only our general solution for the given equation. What is the given equation? Y into 1 plus 1 by x plus cos y into dx plus x plus log x minus x sin y into dy equal to 0. So this is the way to calculate the general solution for the exact differential equation. Just I want to recall you what are the steps we are doing. First, we are taking the given equation, we are comparing with the general form, that is m dx plus and dy equal to 0. And second step we are doing, we are identifying the m value and n value, and we are going to calculate dou m by dou y and dou n by dou x. And third step we are checking about the exactness, and dou m by dou y should be equal to dou n by dou x. After then we are calculating the final step, that is we are going to calculate the general solution. What is the general solution? Integral m dx plus integral n dy equal to c. So here y is treated as constant, and for the n we will take only y terms. So this is the procedure, and these are the steps we followed here to solve the exact differential equations. So to get the more problems, you can take these references books. So here see Higher Engineering Mathematics textbook written by V.S. Cravel, and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and Higher Engineering Mathematics by P.V. Ramana, and you can use one more textbook also. So Engineering Mathematics written by T.K.V. Iyengar, S-Chan Publications. So you can use these books for the more problems and to get the basic points about these differential equations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.